The James Webb Space Telescope's fundamentally accurate image of Proxima Centauri b provides remarkable insights into a potentially habitable exoplanet. It invites us to travel through the universe to learn more about Proxima Centauri b and to see if this could be the next Earth. A mysterious planet lies within the habitable zone of its star, Proxima Centauri, as we venture into the vastness of space. This planet is more than just a rock. It exists in an extraordinary way. Proxima Centauri b is the closest known exoplanet to Earth, at a distance of just 4.2 light-years. This planet is full of mysteries and wonders. Could this be a different Earth with oceans and abundant life on its surface? There's more to the story, though. Proxima Centauri b isn't solitary in its system. Proxima Centauri c, its companion, orbits the red dwarf star. Additionally, the star system may contain additional secrets. Perhaps another companion has yet to be found. The suspense grows. From its star, Proxima Centauri b receives about the same amount of energy as Earth does from the Sun. Could this truly imply that there's water on its surface and possibly even life? Exoplanets are a new category of planets that we come across as we explore beyond our solar system. Planets that revolve around stars other than our Sun. The universe has an estimated 200 billion stars, so the number of possible exoplanets is immense. Some exoplanets even wander the cosmos like free-floating travelers, unattached to any stars. Among them all, Proxima Centauri b stands out as an especially captivating and intriguing planet. It is closer to its star than the Sun is, to Earth, and its year lasts only 11.2 Earth days. In fact, one side of the planet is always illuminated by sunlight, while the other side is perpetually dark. Let's examine Proxima Centauri, the star around which Proxima Centauri b revolves. The triple star system of Alpha Centauri, which includes Alpha Centauri A and Alpha Centauri b, encompasses Proxima Centauri. The closest star system to our own solar system is made up of these stars. Alpha Centauri A and B form a binary system. With a peak luminosity of less than 2.7, these G-type and K-type stars are the third brightest stars in our night sky and appear as a single entity in the Centaurus constellation. Proxima Centauri, also known as Alpha Centauri c, is a red dwarf, or M-type star that is about 4 times the distance between the Sun and Earth, 4.2 light-years away from the other 2 stars. It is the closest star to us, earning it this distinction. In 1915, Scottish astronomer Robert Innes discovered Proxima, which means closest in Latin. Proxima Centauri is our closest neighbor, but it is not visible to the naked eye. It has an apparent magnitude of 11.13, which is much lower than the limit that the human eye can see, which is 6.5. However, you should not be deceived by that. Proxima Centauri remains an intriguing star. In terms of energy production, red dwarfs, like Proxima Centauri, are among the most efficient. Even though they don't give off a lot of energy, the internal convection processes at their centers keep them going for trillions of years. Proxima Centauri will likely continue to be a main sequence star for another 4 trillion years. However, it is still up for debate whether a red dwarf star like Proxima Centauri is habitable. First, it is a flare star, which means it explodes frequently and intensely. Its habitable zone, estimated to be between 0.23 and 0.54 astronomical units, would be much closer to it than the Sun's because it is a low-mass star. However, it isn't as habitable as it appears. The star of Proxima Centauri b regularly emits intense ultraviolet radiation, which is more powerful than the radiation our Sun gives off. That is correct. It is so extreme that nitrogen, oxygen, and even the tiniest hydrogen particles are stripped away. However, that's not all. A planet's ability to support life does not depend solely on how far away it is from its star. It's possible that Proxima Centauri b does not have a stable atmosphere, which is necessary for controlling the temperature and maintaining a surface that is friendly to water. Without it, harsh space weather conditions would make it nearly impossible for living things to exist. Even though Proxima Centauri b's surface may resemble that of Earth, it is far from capable of supporting life. Because of numerous factors, it is inhospitable, so scientists remain cautious. The mission to uncover Proxima Centauri b's truth continues. The James Webb Space Telescope is one instrument that astronomers have focused on. The telescope was finally launched in 2021 after years of anticipation, and it will aid in determining whether or not there is life on Proxima Centauri b. However, as with everything in science, there is never complete clarity. To ensure that the James Webb Space Telescope provides accurate images, a number of adjustments were required. If a planet like Proxima Centauri b can absorb light from its star, it can also emit it as infrared light, says Harvard theoretical physicist Abby Tabor. The James Webb Space Telescope was designed with infrared light detection in mind. It is able to take pictures of this light coming from the planet's surface and look for patterns that might point to water or an atmosphere. However, what if the planet's atmosphere is hostile to life? Ed Turner, a Princeton University astrophysicist, warns that the existence of an atmosphere does not guarantee the existence of life. Similar to Venus, Proxima Centauri b may have extreme temperatures and an atmosphere that is significantly denser than Earth's and thicker than Venus's. There are obstacles in the path of deciphering Proxima Centauri b's mysteries. While the James Webb Space Telescope looks promising, there are other things to think about. Space scientists are under pressure to find ways to observe planets like Proxima Centauri b as costs rise. Although the rewards are even greater, there is a lot at stake. It is a worthwhile endeavor to pursue the opportunity to investigate the unexplored, to discover the secrets of a faraway planet with the potential for life. Could we visit the exoplanet in the future if it were habitable? Because it is the closest exoplanet to us, exploring it is almost like going into our own backyard. Even more fascinating is the fact that it is roughly the same size as Earth, and that its location in the habitable zone suggests that it may indeed possess life-supporting conditions. Additionally, Proxima Centauri b's close proximity makes it an ideal target for our search for extraterrestrial life. It is a prime candidate for interstellar missions due to its close proximity. Consider exploring this Earth-like exoplanet. Despite the fact that we are unable to visit it at this time, it is unquestionably on our radar for upcoming missions. It is one of the most exciting endeavors in the field of space exploration as technology advances. However, the journey is far from straightforward. At its current speed, a spacecraft like Voyager 2 would take approximately 75,000 years to reach the Proxima Centauri system. Nevertheless, solar sails have been suggested as a potential solution. A spacecraft could use these ultra-thin, reflective sails to propel itself toward the Alpha Centauri system, including Proxima Centauri. Utilizing sunlight's radiation pressure, this technology maintains its trajectory without the use of conventional fuel. Even more fascinating is the possibility that this cutting-edge method of propulsion will shed light on the existence of life on distant worlds like Proxima Centauri b. However, there are limitations, as with any bold idea. For instance, just having an atmosphere does not necessarily mean that it is habitable. It's possible that Proxima Centauri b resembles Venus, which has a thick, scorching atmosphere that makes it impossible to live on its surface. In addition, emissions can be detected by the James Webb Space Telescope, even if they only make up 5% of the planet's signal. The planet's day-side brightness is notable. Although it may not seem like much, the host star's relative dimness, in comparison to our Sun, makes it quite significant. If advanced civilizations reside on Proxima Centauri b, they may even use enormous orbital mirrors to redirect sunlight from the constant day side to the dark side. That is absolutely fascinating. There are numerous exoplanets in the universe yet to be discovered. From massive gas giants to planets that resemble Earth, these celestial bodies come in a huge variety of shapes and sizes. The gas giant, whose composition is similar to that of Jupiter and Saturn but is frequently much larger, is an intriguing type of exoplanet. Because they dwarf even the largest planets in our solar system, some are referred to as super Jupiters. However, that's not all. There are also hot Jupiters, massive gas planets that orbit very close to their host stars and exist in environments so hot they could melt metals. Imagine being in close proximity to such a planet, with its violent storms and scorching temperatures. There are Neptunian exoplanets, similar to Uranus and Neptune, as well as gas giants. Among these are hot Neptunes and mini-Neptunes, which are smaller, closer-in versions of their gas giant cousins. Due to the difficulty of observing these planets from a distance, their atmospheres are frequently shrouded in mystery. Let's not overlook Earth-like exoplanets, worlds that closely resemble our own. These planets range in size from being slightly smaller than Earth to having masses more than twice that of Earth. These include super-Earths, which weigh less than ice giants like Neptune, but are larger than our own planet. Proxima Centauri B, which orbits the star of the same name, is one of the most captivating exoplanets discovered recently. With a mass estimated to be approximately 7 times that of Earth, it is categorized as a super-Earth. Despite its proximity to its star, it may still be outside the habitable zone's traditional boundaries. Proxima Centauri B is not the only one. Proxima Centauri C, further out in the system, is its sibling. Using archived Hubble Space Telescope data, this planet was confirmed in 2020 to have completed one orbit approximately every 5 Earth years. The possibility that a ring system reflecting starlight makes Proxima Centauri B an exceptionally bright planet is even more intriguing. However, the suspense does not end there. In 2019, astronomers discovered a peculiar variation in the radial velocity of Proxima Centauri, possibly indicating the presence of yet another planet. If found, this planet would be named Proxima Centauri D, and it is thought to be about the size of Mars or Mercury. Imagine not only a night sky filled with stars, but also a plethora of alien worlds, each with its own characteristics, climate, and orbital patterns. Exoplanets are one of the most intriguing surprises in the universe. The cosmos is a treasure trove of surprises. It is an exhilarating time to be a planetary scientist or astronomer because new exoplanet discoveries are frequently made. Exoplanets are as numerous as stars themselves, despite the fact that we do not yet know their exact number. However, there are significant obstacles on these far-off worlds. Direct observation is extremely challenging because they are frequently obscured by the brightness of their parent stars. However, recent technological advancements have enabled direct imaging of some exoplanets. For this to happen, a planet must be large enough, far enough from its star, young enough, and hot enough to glow in the infrared. These are very specific circumstances that restrict our ability to observe. Nevertheless, even these few glimpses are extremely instructive. The majority of exoplanets are discovered by their effects on their stars rather than through direct observation. Astronomers observe a phenomenon known as radial velocity, which occurs when a star wobbles as a result of the gravitational pull exerted by an orbiting planet. Using the transit method, NASA's Kepler Space Telescope discovered minute dips in starlight as planets pass in front of their stars, revolutionizing this field. We now have valuable information about planetary sizes, orbital distances, and surface temperatures thanks to this approach. Here are a few interesting facts. Planets the size of Earth are thought to reside in the habitable zones of over 22% of Sun-like stars. Additionally, there are 7 rocky planets in the TRAPPIST-1 system, some of which may contain liquid water. Numerous exoplanets are likely to have natural satellites or exomoons, like the moons in our solar system. We know that there are many exoplanets in the galaxy because over 4,000 have been confirmed so far. Hot Jupiters are still the easiest to find due to their enormous mass and close proximity to their stars, but thousands of other types of planets remain undiscovered. These endeavors are being led by NASA's James Webb Space Telescope, which is revealing cosmic secrets with each passing day. This remarkable observatory continues to collect in-depth data and breathtaking images, shedding light on phenomena we could only previously speculate about. It recently made a groundbreaking discovery, the first definitive finding of carbon dioxide in the atmosphere of an exoplanet. This planet, which is 700 light-years from Earth and orbits a sun-like star, sheds light on its chemical composition and evolution. It signifies a significant turning point in our pursuit of extraterrestrial life. Bill Nelson, the administrator of NASA, emphasized that this discovery provides a brand new perspective on the universe, eliciting excitement from the global scientific community. There's even more. Infrared images of the universe have been captured by the James Webb Space Telescope. In one instance, it observed the object IRS-4, which shines light on a cloud of cool, spherical material. Orange hues indicate the glow of distant stars concealed beneath layers of ice and dust behind it. The Ice Age Initiative, which is investigating how ice forms in space, from icy comets to interstellar grains, includes this study. In addition, the infrared structure of a dusty disk surrounding a nearby red dwarf star has been imaged by the telescope for the first time.